quantum physics isn't well understood. It has a reputation. Even scientists get out in front of public and say that it's counterintuitive and mystical. So when someone repeats that, you're inclined to believe it, especially if you have a problem where you went to a doctor and the doctor didn't help you. Now you're inclined to distrust science. And so when someone comes along, the rogue scientists that real doctors don't want you to know about, you feel compelled to believe them. I have the backing of this miraculous, super mysterious and complex theory. It's way better. People buy into it.
I'm very much looking forward to this episode. I have been for quite a while since I heard about your book. I feel like the world of quantum physics is one which is used by all manner of different people to explain things that they absolutely shouldn't be. But why should we listen to you as some sort of judicial assassin of quantum physics? What are your credentials? Who are you?
Well, I'm an associate professor of quantum physics at the University of Technology, Sydney, in Australia. One of the big places to do quantum technology research and development. And I've been studying quantum physics for 20 odd years now.
You've also written 60 books on science in one form or another.
Yeah, I have quite a few. Most of them are children's books. So the latest one probably shouldn't read to children. And because of the place I had to sit in my house for the people watching anyway.
Yeah, that's a lot of alcohol.
Not for children.
Yeah.
You need it to study quantum physics.
So what are the different types of quantum bullshit? Talking about quantum physics, there are ways in which people misuse and abuse and misappropriate it. What are the broad buckets of quantum bullshit?
Yeah, so in the book, I go through the major concepts in quantum physics. So like buzzwords that you might have heard: superposition, entanglement, energy. And they each have their own brand of bullshit attached to them. There's sort of the good, the bad, and the ugly. The ugly is when it comes to quantum energy, which is associated with things like quantum healing, which suggests that people do things that are unscientific and not medically sound in lieu of actual medical attention and medical advice. So that's very bad. And then there's like mundane things when people misinterpret, say, entanglement as some spiritual connection between things that are separated. Which, if you're not stealing people's money and you're not harming people, no big deal. So there's a whole kind of range from harmful to just annoying and head scratching if you're an expert.
Okay. Who are the biggest culprits of quantum bullshit in your view? Do you remember the FBI had that deck of cards? And there was like the ace of spades was number one and so on and so forth. Who would be in your deck of cards?
Yeah, that's a good question. In the book, I try not to give much attention to specific instances because, I'm afraid someone will go there and be like, oh yeah, that feels good to me. I'm going to go with that instead of the difficult.
Thankfully, everyone watching this is way too rational for that to be a concern. Yeah. So you have carte blanche.
I think probably the most famous example is Deepak Chopra, who's been at it for a while. He had a book called Quantum Healing, going back ages, but that's that kind of stuff has been debunked many times over, but it keeps coming back, right? Someone will debunk it, he'll kind of disappear, and then he'll discover like YouTube, and then he'll blow up again because he has a new audience of people that didn't listen to the debunking. So I think he's one of the worst examples, I would say, just because he has such a huge influence and a big platform. Most of them they just disappear almost as quickly as they arrive. If you've nobody's done this, but like if you actually kind of click on a link that you shouldn't, it usually takes you down this path of websites that look like you might be able to put your credit card information in, but sometimes you can't even do that. Like the websites don't even work. Like you have to be right on the ball if you want to actually waste money because they just happen so quickly.
Mere quantum fluctuations in the world of quantum bullshit.
Yeah. And then there's obviously, YouTube videos. It's endless, right?
Are you familiar with Gaia? Have you heard of that?
Gaia?
Yes.
Like the Hindu god?
It's a streaming platform that's
Oh, okay.
reappropriated the name of a Hindu god. And it's like Netflix, but for sort of spiritual woo stuff.
Okay, yeah.
I fear that you may have had an aneurysm if you discovered this before you wrote your book. But yeah, man, I mean, from what I know and from going through your work, it seems like Deepak Chopra would probably be pretty high up on the list. Didn't you go on his show or something, or didn't you have an interaction with him?
I went on one of his shows, the one called The Chopra Well, and that was for my last book. So the last book was called "Where Did the Universe Come From?" and Other Cosmic Questions. It's kind of, I referred to it as my love letter to quantum physics, whereas the latest book, Quantum Bullshit, is my hate mail. And it because it talks about how quantum physics, explains everything we know about the universe even on cosmological scales. It it really kind of connected with his point of view and his audience. I was really surprised, actually, when I spoke to him. I was totally expecting to have to, argue with him, debunk his, nonsense. But he genuinely, when you talk to him one on one, he's just a really, really insatiably curious person who just wants to know everything, right? And he has this internal mental model, and he's just extracting all this stuff, and he doesn't spend enough time to actually go through it and dive deep. And so he's just at this superficial level, and that's a real problem. I mean, if you've seen like the Dunning-Kruger effect curve, right? He's at like the peak of misunderstanding.
What's it called? The chasm of ignorance or something?
Yeah. So he says a lot of stuff. I think he believes some of it genuinely, and others, it's just him. Like he's you do something for so long and you're just good at it, and you have no choice but to do it. And he's really good at just spouting things that sound profound but are basically nonsense. I don't know how. I think it's he's sitting there. I don't know how harmful he is anymore. He's just an old dude, right? Who someone puts a camera in front of him and he starts talking, but the movement around him, I think, is it's steamrolled, it's unstoppable, and that's the really harmful thing.
One of the key terms that you're talking about here is quantum energy and energy medicine and quantum healing and stuff like that. What are the claims that are made by the people that talk about this stuff?
Well, there's this idea that okay. So some of it is like morally true. You have to distinguish between like colloquial notions of energy that we all use today, right? That we tell children, and all energy comes from the sun, and plants take in energy from the sun, and that's where we get our energy. And if you don't eat, then you'll feel tired because you need energy, right? These are all just like colloquial definitions, but there's technical definitions as well. And people often mix these up, and they'll say, well, I have my my everyday notion of energy, and then I read this thing about quantum physics and energy, the concept there, and they feel similar, so that supports my interpretation, right, which is not grounded in science. So with energy, it's that there's this latent energy that's just spread out throughout the universe, and you can somehow tap into it if you you think hard enough, or you meditate, or you pull out your credit card and spend $20 or whatever. But that's not how energy works, right? There's no kind of mystical source of energy, right? Scientifically, it's measurable, and that's.
Well,
how
do you know? How do you know that there isn't quantum energy?
Well, I don't. But the thing is, okay. I know that there is quantum energy, right? I mean, that's sort of what we study and what we research and what I teach to students. But it's not the same kind of energy as this mystical force that permeates the universe. How do I know? Well, I think that's a deeper question. I mean, it's somewhat a philosophical question. Like, what does it mean to know something? In science, we have a very clear notion, right? If you can measure and perform repeatable experiments, and those experiments give similar or the same results, then we can say that we know something, and we assign some objective notion to that. At least an intersubjective notion that we all sort of come to agree that we're going to include that in our mental model of reality. That's how it works in science. So unless you can measure it and you can tell someone the procedure by which you measured it and they can repeat it, then it's not scientific. But that doesn't mean it's wrong. It's just probably useless.
Right. And when people talk about energy healing, they're not just talking about repurposing their kilojoules from a Snickers this afternoon into somebody else's body. They're talking about tapping into some sort of extra special quantum field that gives them the ability to go in and fix your past trauma or your athlete's foot or your gluten intolerance or whatever it is that you're dealing with.
Yeah, exactly. Yeah, that's right. So if you can put a number like kilojoules on it, then it becomes measurable, and then you can make predictions and say what you could do with it now it's been connected to the rest of the scientific corpus, and you can start to make use of it.
Why is it the case that spirituality is such a hotbed for so much of this stuff? It's like a quantum theory of the gaps almost.
Yeah, that's right. We do have a desire to know. Like, as humans, we despise uncertainty. We want to have some idea that we have everything sorted out. And when there is a gap in our knowledge, we just can't help but fill it. And really, the problem is sometimes it's not fillable, and so you get people that come in and provide very attractive options to fill these gaps, and people maybe just don't have the time or energy or understanding to know when they should use a proposed solution or not.
But what is it about quantum physics specifically, do you think, that's allowing this speculation to be sucked in?
I think the recipe is like, you have you start with some problem. You gave some examples: athlete's foot, or trauma, or whatever, and then someone comes along and says, that's a really, really hard problem, right? And it's going to take some complicated, almost miraculous solutions. I happen to have those, right? And don't worry, because I know quantum physics, and if you know anything about quantum physics, it's super complicated, and it has all this counterintuitive stuff. So don't worry about all that. Just know that I've talked to the experts, or I'm an expert myself, and that sort of placates the person into accepting this miraculous solution. So I think that's kind of the crux of the problem, right? That quantum physics isn't well understood. It has a reputation. Even scientists get out in front of public and say that it's counterintuitive and mystical, and then so when someone repeats that, you're inclined to believe it. And if especially if you have a problem where you feel like you've somehow tested out sort of the scientific route or the medical route, like you went to a doctor and the doctor didn't help you, right? Didn't give you the right pills, or didn't give you a procedure to fix your problem. Now you're inclined to distrust science. And so when someone comes along, the rogue scientists that real doctors don't want you to know about, then you're kind of you feel compelled to believe them, because they're somewhat aligned with you, right? They say, well, I'm against the status quo. I'm against convention, and I have the backing of this miraculous, super mysterious, and complex theory. So it's way better, and yeah, people buy into it.
Yeah, there's a number of elements, I think, of quantum theory, the sort of quantum world, that lends itself to charlatans and grifters being able to insert themselves. One of them being the fact that it is not particularly easy to understand. Even me, who's done episodes with Michio Kaku and Sean Carroll and a shit ton of different physicists who are very, very highly acclaimed, if someone asks me over a cocktail party to explain what quantum gravity is or quantum theory or why we can't reconcile general relativity with quantum gravity, I can't explain it. I can't even begin to explain it, right? And I've had hours and hours of conversations about it. So first off, you have a topic which is difficult for people to get into. That means that someone can be a gatekeeper to knowledge, kind of in the same way that in the Middle Ages, the Bible was not translated into the common language because that meant that the priests and the clergymen were the funnel through which your communication with God could only occur, right? You had to go through them. You were beholden to them because it was the only way that you could access this kind of information. And it kind of feels the same way. On top of that, I do think that, I'm going to guess that you would agree, a lot of the information that you find out at the quantum level is very different to what we experience up here at the big sort of level. Everything kind of behaves in a very different way. It's almost like a different universe, right? It's part of our universe. It's just really, 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 really small. But it behaves in a different way. And that makes people think, oh, well, maybe because it behaves in a different way, there are some degrees of freedom that allow me to extract that type of movement and momentum and energy out into the real world. And I can kind of insert my own choose your own adventure, choose your own energy healing thing into that world. And when you have that, the difficulty of being able to understand the blurriness around what it is, and certain people that are able to posit themselves as experts, it is just a breeding ground for people that are charlatans and grifters. My roommate, Zach Tallender, has this thing he calls the charlatan playbook. And diet is another one of these because, even the best dietitians on the planet, it's really hard to do the interventions. We don't particularly know what's going on, despite the fact that everybody eats multiple times per day. And there's a ton of contested stuff around it. Where do they insert themselves? Right into diet, because it's this gate-kept knowledge and it's kind of hard to understand and you can sort of wish it, think it, believe it, and achieve it. So I understand why I think both spirituality that attract a particular type of person, some wishful thinking, a lot of placebo effect, some of this sort of spiritual woo language, and quantum theory, the world of quantum physics, which is like the scientific counterpart to that with sufficient unknowns and degrees of freedom that people can make it happen. I can see how that would be a marriage made in hell, perhaps.
Yeah, quantum avocados. No, I think that's a very... yeah, you hit on some really good points. I totally agree that, but I guess sometimes public engagement, scientific communicators do act really as the gatekeepers of knowledge, and I think some of them enjoy being in that position, rather than maybe they set out to say, I'm going to educate the world on my particular topic of interest, and then they quickly, buy into the fame, right, and become sort of the gurus. And I can imagine, it feels good, when people
it's alluring, man.
ask you,
being the fucking gatekeeper of this knowledge, it's alluring.
Yeah. I haven't made it that far yet. So I'm still.
That's next. I'm waiting for the quantum energy healing that doctors don't really want you to know about. Pivot for Chris Ferrie. So one of the other terms that a lot of people listening will have heard about will have been vibrational frequencies. What do you think people mean, or what do you think people think they mean when they talk about vibrational frequencies?
Yeah. Well, let me just point out that just so that there's a clear demarcation, right? So energy, the conventional concept, our everyday notion of energy, is that it includes the idea that it flows, right? It's continuous. And what quantum brings to the table is that that's not true at the most fundamental level of understanding we have. Energy comes in discrete chunks. So energy is not like a slide that you can go up and down. It's like steps. You have to be on a step. These steps are incredibly tiny. You'd never notice them in everyday life, but they're there, right? So that sort of the difference between quantum and classical energy. That's never actually used in any of the bullshit, right? They don't actually use the real kind of concept of energy. But frequency is similar. So again, we kind of understand that how energy is mediated between things is through waves. So there's electromagnetic waves that we're using right now to communicate over the internet. There is sound waves that come from the speaker in your headset or on the speakers on your device. That's vibrating air molecules. That's traveling as a wave. So waves carry energy. Now, in order for that energy to be received, that thing has to resonate. So it's just another one of these words that has many meanings, right? There's colloquial meanings and there's technical meanings. They're very similar. So when you say something resonates, it's like you're in tune with it. But technically, it's when the wave that could potentially interact with the thing is around the same size as the object. So if you think about waterways, I think is an excellent example. So imagine, you're a boat and there's an enormous swell in the middle of the ocean. You wouldn't even notice, right? Like you look around and it looks like it's pretty flat around where you are because you can't see the next peak in the wave. And if there's tiny ripples, you wouldn't notice those as well. When do you notice a wave if you're a boat? It's when the distance between the peaks is about the same size as the boat, right? So that one end of the boat is at the top and the other end of the boat has gone to the bottom. So when things are around the same size as the wave, that's when there's an interaction, and that's when you quote unquote resonate with it. So there's example. Just sort of look around you, and there's examples everywhere. Like
it's why we can't hear microwaves, right? Or we can't see radio waves.
Yeah, so that your eye is basically tuned to only the visible portion of this vast electromagnetic spectrum that includes radio waves, infrared, microwaves, and then the other end, higher energy waves like ultraviolet, X-rays, and gamma rays. They're all hitting you all the time, right? But you can only see the visible ones, and that's just an accident of evolution because it seemed to be useful for survival. Now, so people think that they can somehow, I guess, in the implicit assumption is that they can change something about themselves, what they think or what they do, so that they can tune to some wave that's out there. And well, that's just somewhat ridiculous. I mean, it's true in like a a sort of mundane sense, right? If I uncover my ears, then I've allowed my hearing apparatus and all the stuff that goes on inside my ear and my brain to be in tune with those waves. Or if I open my eyes, I can be in tune with visible light. But there's nothing I can do to see infrared light unless you trust scientists and engineers and use technology. Then of course you can. But you like we're pretty limited when we think about the biology of these bodies that we're carrying around.
So when people say vibrational frequencies, what they're probably talking about is their emotional state, how they're receiving other people's emotional states, what they're putting out into the universe, and how that's impacting a field, the quantum field, perhaps.
Yeah. So you do have like several wavelengths associated with you and different parts of your body. Again, like your retina is associated with a certain wavelength that's tuned to visible light. Your eardrum is associated with wavelengths of sound. what 15 hertz up to however, whatever it is, 44,000 hertz. And your entire body can act like an antenna as well, which is tuned to roughly 10 hertz. So if someone was blasting a speaker that was 10 hertz, and if you've been to concerts, maybe you kind of can feel this, right? Really, really low bass, some of which you can't hear with your ears, but you can feel in your body. That's because you are an antenna, and certain parts of your body will resonate with electromagnetic frequencies as well, and those are regulated by the FCC. Sometimes because it's unhealthy, but most of the time just because if human bodies are absorbing the signal, then you're not going to be able to get signal to your smartphone. So don't use those frequencies, right? Like, engineers don't think of humans as things that they don't want to harm. They think of things that are in the way of their Wi-Fi signals. Now there is this notion that, like, if we agree on something or we have the same opinion, then somehow we are in tune, right? That opinion resonates with me, which is it's a fine way to communicate, and it works because it's embedded within a system of language that we all understand and we can make use of. But it has its limitations, and if you start to say that it does things beyond just helping social interactions and people come to agreements, then you're in trouble, because those things aren't verifiable.
And by this, we're talking about someone genuinely having a physical connection between themselves and somebody else, that them and the other interlocutor are moving or attached through some kind of quantum wave or quantum energy field in a strange way.
Yeah, that's right. So that if that were true, then you should be able to measure it, right? And if you can't measure it, then you can't verify it. So it's just magical thinking otherwise.
But how much quantum physics can we measure? Is it possible, in your view, as somebody who has spent an awfully long time studying quantum physics, that this could be something that exists? Or is the only way that this exists if it is tapping into something which is outside of the field of quantum physics, most likely?
So you could take this point of view, right? That everything in the world is just atoms, right? Nowadays we teach this to children, or at least I do, that all of this stuff around us, including your body, is made of atoms. And the world is just everything you see is built up of several of 118 elements that we often see arranged on the periodic table. That's it. That's all there is to the universe. Everything is just a bunch of these atoms stuck together in different arrangements. And their interactions are mediated by electromagnetic waves. So with that understanding, there are things that are just ruled out. So I can't have a physical interaction with you. I mean, again, it's somewhat subtle, right? Because in some sense, I can influence you, right? If I pause for long enough, then you'll probably say something, and that's happening at a distance. But so it really depends on the kind of claim that you want to make, right? They're seemingly miraculous things, and you apply a simple rule, right? If it sounds too good to be true, then it probably is. So if it sounds too good to be true, then it's not part of science and not part of quantum physics. Quantum physics is used to explain this idea of the world, that everything is made of these fundamental building blocks, and what we see around us is just a built up of many, many interactions of many of these things. And we understand that to an extent that our entire modern world is built on quantum physics. Everything around you, the device you're using, the scans you get when you go see the doctor, compact discs, if anyone remembers those, lasers, clocks, GPS, the internet, computers, everything is built from this understanding that the world is made of atoms. And if we put these together in various ways, then we can put that to good use.
I was on a boat party talking to a girl that was part of another group that had turned up, and she seemed perfectly nice and was explaining about her young son and what she hoped for him in the future and the job that she was doing and all of the rest of it. And I was asking about how she'd changed. She made some job changes recently, I think. And she said, yeah, I just really started raising my frequency. And I thought, well, now I'm interested. And I asked, what do you mean when you say that? And she said, well, I sort of changed the way that I thought, and I adjusted my emotions. And I said, yeah, okay, but what about the frequency thing? He says, well, emotions have got a frequency. They vibrate at a frequency. I was like, okay, what do you mean by that? He says, well, they vibrate, because they vibrate at a frequency, and I changed. And I was like, right, but what do you mean by that? And I kept on asking the what question, and it resulted in her saying the sentence, I believe in quantum physics. Like, this
Right.
was some like a walled off garden, a castle that she could retreat into that would
Right.
explain something that I didn't understand, but self-evidently neither did she.
Right.
I believe in quantum physics. And she did leave not long after this. I think that I was very polite. I didn't, take the piss. But I did push a good bit to say, what do you mean I raised my frequency? What do you mean emotions have a frequency and they vibrate at a frequency? And what do you mean I believe in quantum physics? Like, genuinely, for the love of God, what the fuck do you mean? And I don't think that she really knew. And I think this kind of taps into what you're talking about with the good, the bad, and the ugly of quantum physics, and also maybe even Deepak Chopra as somebody who, from the outside, might seem willfully negligent or kind of like jovially ignorant, purposefully ignorant in a way that benefits perhaps himself. But it can start people down a slippery slope toward believing in things that become increasingly and more disempowering and less accurate to the world around them. And it can also cause people to do things like abandon their cancer treatment in place of going to do crystal healing and stuff. I'm pretty sure that, wasn't it Steve Jobs who decided to try and do some very holistic sort of woo things to try and cure his, was it pancreatic cancer, incredibly treatable, 90% recovery rate, had he have just decided to go and get standard treatment from Western medicine. And he went to somewhere in Tibet or India or something and sat in a cave and had some treatment. And, we lost one of the greatest marketers and product inventors of ever because of that, which shows that it doesn't really matter how smart you are, that these kinds of ideas, I don't know how quantum-y Steve Jobs' worldview was, but these ideas can take a hold of people. And it is a very slippery slope. If the thin end of the wedge is just believing in entanglement and two people that love each other have an emotional connection that transcends space, time, and physics as we know it, it is just a difference of degree all the way down to, I don't need chemotherapy because I've got some tiger stones at home.
Yeah, no, that's right. I mean, we like to say, okay, that's innocent, whatever. But I think the issue is that, again, people want simple stories, right? And once they have a story that they're comfortable with, that they stick with it. As scientists, this is just our basic state. In order to make progress, you need some assumptions, right? But we're always ready to abandon those assumptions when they lead us astray. So if you accept some set of assumptions, some story, then you're eventually going to be led down that down the wrong path if you need to have every new piece of evidence or new piece of information fit within that story. And extreme examples are like conspiracy theorists, like flat earthers, right? So in order to believe that the earth is flat and then be told that people live in Australia, in order to make those two things like fit together, right, you have to say like we're all actors, right? And we're in Hollywood and there isn't really a place called Australia. I mean, some of us don't even have Australian accents. But that I think is the problem, right? That I'm fine with people making assumptions and having simple stories. I do it all the time, even within a scientific context. But you have to be ready to abandon them when those analogies, those stories, no longer are fit for purpose.
You had a quote in the book from Quantum Love, and you said, when you use the power of the quantum field, honing your emotions and intentions to create the frequency or vibration of that desire, you will draw the things you want to you.
Yeah, no, that doesn't work like
what
that.
The fuck does that mean?
That's an interesting book. I think probably one of my favorite examples of quantum bullshit, because the person who wrote that book, Dr. Laura Berman, I think she's Oprah's love expert or relationship expert or something. Has a PhD from New York University.
In what?
Probably sociology. I don't know exactly what it is.
That's right. Dude, the seamless pivot from sociology into fucking quantum physics is so brazen. I work so hard to gain fucking millimeters every single year in self-confidence, and then there are people that decide to abandon social science and just dip into quantum theory. Like, fair play. You know what I mean? Yeah. Fair play to it.
Well, I think, yeah. I mean, if that's allowed, then I can give people relationship advice. Why not?
Damn right.
But so she, in her book, actually, if you read like the first chapter, it's her explanation of quantum physics, which reads like something that would be in Scientific American or some popular science magazine. It's not accurate, but it's no less accurate than what you would see from even a science journalist. And then the problems start to arise is when she tries to connect that to her particular area of expertise. But yeah, I mean, all relationship advice is the same. It's just, it has different sort of layers of bullshit slapped on it. And she decided, there's a gap. Throw quantum physics in there.
Make it quantum. Quantum love.
But then when you make a claim like that one that you just read out, that is a very specific claim, which is comically untrue. I don't know. Again, there are all of these cognitive biases that come in, right? So if I say, okay, well, I read the book and I did the sort of exercises that she suggested, and then I played the lotto and I won $20. So it must have been that, right? So there's confirmation bias happening all the time, right? Because the other 100 tickets that you played didn't win. So yeah, again, it's these huge gaps and all of these cognitive biases that people aren't aware of that allow these things to thrive.
Well, there's also a placebo effect, which is unbelievably strong, right? And I'm kind of torn, and this is more an ethical question, but the placebo effect, or the expectation effect, as David Robson would call it, which kind of expands it out from taking substances to expectations too that we have around the world, is the most reliable effect in all of pharmacology or medicine, right? If you could bottle it, you would have a panacea. And, they've shown that studies where people take sugar pills, that they've been told are sugar pills, have better outcomes than people that don't. And they've been told that it's a fucking placebo. So, I disregard the expectation effect as little as I can. I think that it is very, very useful. But The mechanism that this thing is working on is not what's being claimed. The outcome can be something which is positive in the direction of what you wanted to occur, but the mechanism that you said it operated on is not accurate. And is conning people or duping people or lying to people or convincing them that a particular thing works worth the outcome, because the only way that that outcome can be achieved is by getting them to believe it, which means that you need to give them a sufficiently convincing lie? I'm not sure. And I'm definitely not sure when there is a slippery slope down toward believing things which stop you gaining some of the benefits of expectation effect and actually start causing you to believe a whole host of other silly woo.
Yeah, I guess the issue I think is that there's a huge gray area, right? There is no truth, right? We have models of reality. We have these simple stories that tell cause and effect relationships of chains of events, but these aren't true in any universal sense of the word. There is no universal truth. There's a big gray area, and when you think about it that way, you can start to see, okay, well, there are things that are more truthy and things that are clearly untrue. But even our best theories are just useful theories. They're not true theories. So our understanding of how the placebo effect works probably has something to do with human psychology, and potentially we can get down to chemicals that are being passed around within our body. And at some point you can say, well, those chemicals are made of molecules which are made of atoms. So, it's all, at some point it's all can be understood as being based on quantum physics. But I think you have to have these different layers of explanation and accept that at any point, none of them are true in any objective sense of the word. They're useful. So I think we should accept these lies if they give us mileage. But as soon as they stop giving us a return for believing it, then we should abandon it. So if you want to say, well, this placebo effect works because there's some quantum interactions that are happening in the brain, and if you think the right way, you can make those align, and that achieves the outcome that you want. The person gets better. That's great, but maybe everything should just have an implicit disclaimer, like your mileage may vary. If you use this model to do something else, it probably won't work.
The problem that you have there is that stopping people at the bounds of this is what it's good for and it's not good for much else, or it's good for a small number of things, isn't the way that human brains work. If we find success and win 20 quid because we did our right energy crystal healing and tapped into the quantum realm, I mean, that's going to fix everything. Like, my chronic flatulence is fixed by it. My erectile dysfunction is fixed by it. Like, everything. Do you know what I mean? Moving on to another very common question around quantum physics: uncertainty, the uncertainty principle. What are people getting wrong about Schrödinger and his cat and uncertainty and all the rest of it?
Yeah, so this one's I would say is one of the probably more mild ones. So it's just such an abstract concept that I don't think it's made its way into these other these other places.
No one's found a way to monetize it yet, is what you're saying, Chris.
Yeah. So uncertainty, it's kind of the hallmark of quantum physics. And there's this famous story that how it was discovered by Werner Heisenberg, who had hay fever, so he secluded himself on this island. And it came to him in a dream or something like that. He woke up one morning and had to write something down, and it wasn't like, oh, he just wrote it down on a stone tablet and then brought it back to to Copenhagen. It was more he had this idea, scribbled it down, and then he developed it over probably weeks to months, and it was probably some mess when it started, but eventually we retell the story as it was like this eureka moment. where he basically had this idea of trying to measure the property of something. So there's this idea of Heisenberg's microscope. So if you know how a microscope works, a light microscope, you shine light on something, light bounces off of it, and then gets magnified and enters your eye. Then he thought, well, what if the thing I was trying to look at with the microscope was a single atom or a single electron, a fundamental subatomic particle? Well, when I shine light on it, which is fundamentally other particles, it's like two billiard balls hitting each other. So just the simple fact of trying to measure something alters it in some way. So if I shine the light on the electron, yeah, it's going to bounce off and then come and hit my eye, and then I can infer something about where it was and other properties of it. But now I've imparted something onto that electron, and it's going to take off in some other direction, some random direction that I don't know. So his notion was you can't simultaneously know where something is and how fast and where it's going at the same time. You can choose to measure one property, but you can't obtain everything there is to know about both properties. Nowadays, we understand the concept a bit more subtly. The real crux of the issue is that these properties aren't even defined. Like it doesn't make sense to say that there is something pre-existing in the world, and our job as observers is to go and figure out what those properties were that were there regardless of whether we chose to go and measure them or not. So you can choose to measure by setting up some apparatus, measure position of something, find out where it is. But by doing so, by arranging that apparatus, you've caused something else about it to be undefined. So there isn't some pre-existing set of properties in the world. Now, this gets sort of caricatured as, when you measure something, you affect it. And so you see this a lot in popular culture. There's a related effect in psychology called the Hawthorne effect, or the observer effect, which is like if I prime someone before I ask them questions, then the responses will be different than had I not primed them. So if like when you do these psychological studies, like if you know the context of the study, then you're not going to act in a natural way, right? So this is basically why you should take every psychological study with a grain of salt, because people aren't going to act naturally when they're set in a white room with one chair and asked to do a task, right? That's not their natural state. They know they're being observed, so they're going to behave differently. And this sounds similar, like it uses a similar set of words and a similar set of concepts, but it's unrelated. Like the effect in psychology has nothing to do with the effect in quantum physics. They just seem similar.
Yeah, there is a associated phenomenon that people talk about a lot, I guess, which is quantum entanglement, the ability of something to travel faster than the speed of light. And then this kind of gets stretched out to talk about connection to the cosmos, because we're becoming quantum entangled with somebody else through love and spiritual connection and stuff like that. What is and is not bullshit about quantum entanglement?
Yeah, that's a tough one, because it's probably the most abstract and concept in quantum physics. At its base is, if you try to understand quantum physics from the point of view of information, maybe more of an engineering point of view, then a lot of these things become clearer. Again, the issue in quantum physics is that at the same time, it tells us that there is no fundamental reality. There is no thing out there that's independent of us, waiting for us to come and observe it. But in order to make progress as humans with our limited, mental capabilities, we have to create these sort of concrete stories of reality. But as soon as you do that, you've violated the one principle of quantum physics. So we do this as physicists as well, because it's difficult to carry around all of these abstract conceptual concepts. It's much easier to just have some concrete physical model in mind. and then apply our notions to that. So with entanglement, the basic idea is, say you have two particles and you interact them in some way, and then you separate them. And if you've done it in a clever way, then the state of those particles is some special state that we call entangled. And what that means is, if I measure a property of one and I get some outcome which is random, I'll get the same outcome on the other one. And it seems like, because I can choose which measurement to do on one side, that I have somehow influenced the other one. And you'll see this repeated by scientists and in science magazines. And there was a recent article even in the New York Times that quoted a scientist that said exactly this. Entanglement is when particles are separated, and doing one thing instantaneously affects the other one. But that's not at all what happens. This is all of these problems that we've been talking about repeated, but by scientists. Once you've committed to this story of there's physical things in the world, and then you have this other piece of information, that they seem to be correlated in every possible way I can choose, then you're forced to say something instantaneous happened. But that's just not true. There's no influence, there's no information, nothing is traveling faster than light. Now, everything is connected, right? So gravity is a simple example, right? Gravity has no bound, right? The force of gravity drops off the further two objects move away from each other. But there is a force of gravity between you and the moon, and you and the sun, and you and all of the planets and all of the stars, right? It's just imperceptibly small. And the connection, say, between those two is mediated by Einstein's field, but it can't travel faster than light. So there's no sense in which those things can influence me on any time scale that's relevant to me. I can shoot a laser, and it will take a few seconds to hit the moon and back. And if I go further and further away, it just takes longer. So yes, in some real technical sense, everything in the universe is connected, and probably everything has some small amount of entanglement if you try to model it with quantum physics. But that doesn't actually help you do anything that is relevant on human scales, but in time or in space.
How much truth is there in people talking about using quantum entanglement to be able to communicate in the future across galaxies? Well, we could entangle these two things, and then we'll spread them apart, and then that means that we can communicate. Is there a future in which you think that could happen?
No, we're always limited by the speed of light. So if I entangle two particles, take one to Alpha Centauri or something, and then I've done it in a very clever way, used all of our advanced engineering, future technology, whatever. What it means is that they're just correlated, right? It's like photocopying a book, right? But not knowing what's in it. And you separate those two books. What do you know? You know that when those books are opened, they're going to have the same words in them. But you can't use that to communicate faster than light. In order to do anything with it, some more communication would happen. Now, the correlation is useful. You can use these correlations, and in some sense, there's everything about our experience is ultimately about correlations. Like, this conversation deals with correlations. Like, we have a correlated dictionary of English, right? So that when I speak these words, they have a meaning to you because there's this prior correlation that has been set up. But just because that correlation was there doesn't mean we could have said everything that needed to be said without actually having the conversation, right? So everything will be limited by the speed of light, and entanglement is just a new kind of correlation that we can create in the world, and it can allow us to do things more efficiently, but ultimately nothing miraculous. It
Any
isn't going to.
Any sense that two humans can become entangled together?
No. So the quantum, I think the way I like to think about quantum physics is it's a theory about isolation. So when you have an object and you completely isolate it from its environment, then if you use anything but quantum physics to describe that object, and when I say describe, I mean make predictions about the outcomes of experiments that you might do, then you'll be wrong. You need to use quantum physics to describe that object if it's isolated from its environment. Now, if you think about, okay, well, the atoms in my body aren't isolated. Why can I stick it in an MRI machine or something? And quantum physics somehow is what's powering that technology. It's that if you've heard anything about atoms, it's that they are mostly empty space. So maybe you've heard this idea that the chair you're sitting on is mostly empty space, and when you sit on the chair, you're not even touching the chair. There's an enormous amount of space, at least on a small enough scale, between you and the chair. Nothing ever touches, right? And the parts of the atoms, there's vast orders of magnitude and scale between the size of the parts of the atoms, like protons, neutrons, and electrons, and the actual space between them. So basically, everything is empty space. So that's why quantum physics is useful to describe those things, because in some sense they're isolated from the other things around them. Now, if you want to have something as big as a human body to be usefully explained by quantum physics, you would have to isolate it. And well, that means no light, no air, and it would cease to be a human pretty quickly. So yeah, you could get a large, massive object, or two of them, and have them entangled, but it would be nearly impossible to isolate them from their environment, and that's the real issue. Like, the bigger the object is, the more ways it can interact with stuff around it, and so you have to remove all of those possible ways in order for it to start to behave in a way that's different from our everyday experience of the world. And I think the largest thing that we could probably get to be entangled might be like a future computer chip, right? That would be the basis of quantum computing technology. But even then, the apparatus that you have to stick around it in order to isolate it from its environment would be huge. So the places that they put these things. So if you've ever seen a picture of a quantum computer, it looks like it looks like a giant tube, right? An enormous sort of cylindrical vat. And what that is a dilution refrigerator. And liquid helium is used to cool the inside of that thing down to thousandths of a degree above absolute zero, which is that thousands of times colder than even outer space. So we've created the most extreme environment in the entire universe here on Earth, just so that we can, watch an atom do something.
You mentioned quantum computing. You also do a ton of stuff to do with computer science. We're supposedly on the cusp of a quantum computing age, and if we get there, it's going to break all of the algorithms, because everything that we've used to do credentials and security for cryptography is going to be out the window. What can and can't quantum computing do?
Well, we don't know. I mean, a great quote from, I think, like the late 1940s from the then CTO of IBM was, "There'll never be a market in the world for more than 6 computers." So clearly, even someone of that caliber can't make accurate predictions about future technology. So, I mean, I can say a few things, but the disclaimers, I don't know, and nobody knows what this will be useful for. The first application of a transistor was for a hearing aid, right? And now we carry around 1 billion of them in our pocket. Uh, the we have algorithms, so these are like recipes. If you can transform this data into this data, then you can solve some problem. One of them is factoring numbers, and this is what you'd have to do to break current encryption systems that secure the internet. But I don't think that would be a big problem for when quantum computing happens. And we can already see certain people with really important secrets, like state governments and large corporations, that are moving to what's called post-quantum cryptography, different encryption schemes that quantum computers, we think, won't be able to break. So if you say, you have to ask yourself, well, how important is my secret? And important is how long do I need to keep it, right? So you can't keep a secret forever. Maybe you need to keep it for 50 years. And then if you say, well, if someone learned this in 50 years' time, that would be bad. And then you say, well, quantum computers might be around in 50 years, then I should probably switch. But if you're like, I don't care if people know this next year, but I don't want them to know it now.
If someone leaks my nudes in 20 years' time, that's totally
fine. You don't care. Yeah. So you don't have to worry right now. You can keep using
iCloud or whatever. Right.
Yeah, that's fine. But if you think that's really important, maybe you want to switch, or send some customer feedback to Apple, asking them to switch. We say quantum computers will break the internet, but probably not. Most likely not. People are in the process of switching to post quantum cryptography, and when quantum computers become ubiquitous, then we just will use something different. The other thing, I think, the thing that you should keep in mind, the back of your mind when you think about future technology, is that it happens slowly, right? Like, even think about probably the most transformative example would be something like ChatGPT, where it had the fastest adoption of any technology, yet it hasn't broken the way the world works, right? Like, we still basically interact and engage with the world the same way we did before. And the same will be true of quantum technology. It will happen over a longer time scale, but it won't be like, okay, one day you just throw out your old computer and now you have a quantum computer in your house. No, it'll be slowly integrated, and the end user won't have a different experience, because that would be terrible, right? At the end of the day, it's all driven by the economy and the customers, right? And what they want and what they'll buy. Henry Ford could crawl out of the grave and step into a Tesla and happily drive it away. The interface hasn't changed, even though the entire technology behind it is different. So with quantum computers, if you're just an average consumer and you're like, oh, well, what I care about is, will I still be able to use TikTok? Then, of course, right? Because we wouldn't develop technology that, can't be used in the exact same way and sold to the same set of people. The other promising future prospects of quantum technology include things like quantum simulations, and that sounds like just more complicated and annoyingly complex, but it's incredibly important. So when we design new materials, when we design new drugs, and when we want to understand how things are made, we want to understand them at the deepest and most fundamental level possible. So that is basically at the level of atoms. Like, if I could understand what sort of atoms I need to put together to make a super strong material, or to make a material that can conduct electricity without dissipation or resistance, then I could do, there's no limit to the imagination at that point, right? Like, for example, imagine you could make a material called a superconductor that works at high temperatures. And so these are the things that make, like, levitating trains, and maybe you've seen the levitating frog on YouTube. If you could create a material that can conduct electricity with absolutely no resistance, then you wouldn't have to build, coal-fired smoke plants right next to cities, right? You could just throw a whole bunch of solar panels out in the middle of the desert, and the entire world would have free electricity. Why can't we do that? Well, because it's nearly impossible for us to simulate using conventional technology what happens when we put even just a few atoms together. But the number of degrees of freedom and the amount of data that we'd have to track is just impossible for even today's supercomputing clusters, which, still attempt to do this. Like, a huge fraction of the world's energy budget is just simulating interactions so that we can make better fertilizer, right? If you could create a computer that just natively does this without having to attempt to encode all of this information in a really inefficient way, which is what we seem to have to do with conventional computers, then you have all of these sort of dream applications. But we don't know exactly how we would do that with a quantum computer. We have, the basic fundamental idea and some simple examples and some understanding of what would be required. But, if someone dropped a quantum computer on my lap, it's not like I would be able to get going on this right away. So the progress, again, will be slow. We'll see incremental improvements. But, maybe 30 years down the line, and if you look back and say, okay, compare it now to 30 years ago, you'll say it's it's an enormous change.
What about many worlds? Are we part of a multiverse? Is the fact that I decided to say many worlds instead of multiple worlds meant that we've branched off into a different universe as well now?
So this sort of quantum metaphysics, quantum philosophy, it's an interesting place. It's a very interesting place because it's like woo, but it's people with PhDs. So it's kind of like it's a really strange thing. So I think it just goes to show that there's, no matter how much you learn, no matter how educated you are, you can still just get attached to things that are to me comically miraculous. So it's an interpretation of quantum physics. So you have this idea of superposition, and then the cartoon explanation is like things can be in two states at once. But when you go to measure them, only one of them occurs. So you mentioned earlier Schrödinger's cat. So that's like a famous example of you put a cat in a box, and inside the box there's a vial of poison and a hammer, which breaks the vial. But the hammer will only fall if some quantum event happens. So you arrange for that event to be in superposition, an atom decayed or not decayed at the same time. So that means the hammer has broken the vial or not broken the vial at the same time, which means the cat is alive and dead at the same time. But whenever you attempted to perform this thought experiment and open the box, you'd either find an alive cat or a dead cat. Okay, so then the many worlds interpretation says, well, there's a multiverse, and in one branch of the multiverse, there's an alive cat. In the one branch, there's a dead cat. And you, as an observer, are on one of these branches. It's not testable, and it's not. It doesn't simplify anything. I mean, I think for most people, it's alluring because it gives you this. Yeah, it gives you this sense that that you could have done things differently, or that there are better options that you could take. Right? There's another version of me that it was more successful, or didn't have health problems. And I think this idea that you could go back and change things, it's just something that people people like, but it's not based on anything that's measurable. Like, you can't test the many worlds hypothesis.
it removes the pressure of having to make decisions as well. Because if the decision that you make now, whether it be going left or going right, is just one of a number, and it almost creates this like liminal excuse, this kind of get out of jail free card that you have, which I understand. It's psychologically comforting to not be beholden to being locked into the future by whatever decisions you make now. And I understand, there's parts of me that really understands, is it agoraphobia? That's why people sometimes don't like to leave the house, I think. I kind of get that. I almost get the, or the concern around germs and stuff like that. Like that, there's just so many things that could happen that are outside of my control. And if I don't make any sort of decision or commitment, or if I try and change things as little as possible, if I try and make as few changes as possible to whatever state I'm in now, that would suggest that I'm going to stay safe moving forward. It's a fundamental fear of the unknown, the unexpected, the uncertain, the future. I understand why that's psychologically disquieting. But again, with the many worlds thing, if the quantum physicist says it's untestable and therefore difficult for us to work out whether or not it's true, I don't know. You can allow people to indulge in it as a sort of psychologically comforting fantasy.
So the person who developed it, his name is Hugh Everett III, which is the worst. The worst
3 generations of Hughes.
Yeah. He had a terrible life. People didn't take his ideas seriously, and he had this. He also developed this notion of quantum suicide, which was basically that like think about quantum Russian roulette, right? In 6 of the world, there's 6 worlds, in only one of which I'm dead in, right? And 5 of which I live. So, why not play the game? Because I'll survive in one of them. So if you, imagine this sort of thought experiment, right? Like someone says, flip a coin, heads, I give you $1 million, tails, you die. Then you should, if you believe the many worlds, you should play the game, right? Because in one of the worlds, you're $1 million richer, and in the other one, you don't care. So I think it sounds innocuous, but I think if you really took it to its logical conclusion, you'd be forced to also believe some pretty ridiculous things, and that's basically my problem with it.
I've heard you use the term "not even wrong."
Where does that come from? Yeah,
I'd never heard that before. Yeah. Can you explain what that is for the people that are uninducted?
Yeah, I recently was told it goes back to Pauli, which is a quantum physicist. But there's a book by that title, and it is basically about the book was written about these ideas in theoretical physics that are just not testable, right? So you can't even say that they're wrong. So it's just a mental masturbation, essentially, that you come up with all these ideas and theories, and you can say, well, because they have mathematical symmetry, they're beautiful, therefore they must be true, things like that. But a practical person would come along and say, I can't tell you not to believe that because it's not even testable. And, the mental state that you've put yourself in is difficult to get out of. So yeah, it's not even wrong. I can't even say it's wrong. What is it? It's nothing, right?
Yeah, that's maybe one of the most not kind of patronizing, but like good insults or pushbacks that I can think of when someone starts spouting out a lot of horseshit. You mentioned previously that you wrote a book in the past that was a love letter to physics and quantum physics, and this is your hate mail. Did I see on your Twitter that you've been receiving genuine hate mail from some people that are a part of the spiritual community that took a little bit of upset at what you've been pushing?
Yeah, I slough it off, to be honest. It's the recommendation I give in the book is to just not engage. There's no good can come out of it unless you're prepared to put in the time, and it takes a lot of time. So
what have people been accusing you of?
Well, it's, I mean, they accuse me of everything you can imagine, like that. I've lost my way. I need to find Jesus. All
Quantum
that sort
Jesus.
of, yeah, like religious stuff um, to like they have their pet theory, and they'll accuse me that I don't really understand quantum physics because, yeah, and then they'll just repeat something that's, again, not even wrong, and it's not even worth my time to engage, because it would be like the conversation that you had with that woman, that they would just repeat themselves or go in circles. Like,
that was
oh, you
enjoyable.
haven't
That conversation, I actually took an awful lot away from it. But yeah, man, I think as somebody that is a world-class expert at receiving comments from the internet, my theory is absolutely just engage where you want to, and draw the line at that. Like, if you want to find out, I wanted to find out from that girl, and it was a very enjoyable and respectful conversation. And I wanted to find out, what do you mean when you say raise your frequency? What do you mean when you say I believe in quantum physics? What do you mean? What do you mean? That was perfectly enjoyable. It wasn't cantankerous at all or anything else. But the line on the internet is just, don't feed the trolls unless you want to, unless you've got some spare food lying around and some spare sanity that you want to throw at them. I have friends, Destiny, this guy, he's a streamer, and he absolutely breeds for opposition and for antagonism and for debate and stuff like that. And that's his lifeblood. It's like he's a plant, and that's the sun. Whereas for me, and perhaps for you too, that's not how I would enjoy spending my Saturday afternoon. So I would choose to do other things. And I every time that I see some of my smart friends on the internet getting into spats with people, and I understand in some regards, if you use it to kind of make an example to signal boost a bad idea and show how easily it can be fixed, that's not necessarily a bad way to do things. But one-on-one in the DMs or in a message thread or a thread on Twitter or whatever, trying to slowly chip away at some person's worldview, it's like, look, I've done the work. I've broadcasted my stuff in a video or in a book or at a presentation or whatever. And if you disagree with that, that's fine. But I don't know what you think my time or your time or anybody else's time is worth, but I can promise you that it is worth way, way more than trying to convince somebody that doesn't like me and doesn't agree with my worldview that they're in the wrong.
Right. Yeah. Yeah. Don't feed the trolls. I think it's good advice. It will often have the opposite effect than you expect.
You catalyze the trolls rather than
unless you're prepared to put in the time. Like if you have a family member that believes in some conspiracy, then maybe you want to slowly kind of remove those beliefs. But it probably takes. The problem is, like, it takes orders of magnitude more time to fix than it does to create. It take me a second to create bullshit on the internet. And then the damage is almost irreparable, because even if all of the scientists in the world went to debunk that, well, I could just create 10 more pieces of bullshit in the time that took them to do that.
Yeah, have you heard of Brandolini's law, which is what you're describing there?
No.
Brandolini's law, also known as the bullshit asymmetry principle. It takes a lot more energy to refute bullshit than to produce it. Hence, the world is full of unrefuted bullshit.
Yeah.
There you are.
Exactly.
See, there's a law. There's a law for everything, including the production of bullshit on the internet. Dr. Chris Ferrie, ladies and gentlemen, if people want to keep up to date with the stuff that you do and check out some of your work, where should you go?
So the website is csferrie.com, and there you can contact me. You can follow me on all the social media platforms, though I tend not to use them very often. But a bit secret. But you can contact me via my website if you want, or follow me on. Apparently, you can follow people even on Amazon now, so you can follow me on Amazon.
Hell yeah, Chris! I appreciate you. Thank you for today. What's happening, people? Thank you very much for tuning in. If you enjoyed that episode, then press here for a selection of the best clips from the podcast over the last few weeks. And don't forget to subscribe. Peace.